All right, hello, and welcome back to another video. So today we're going to be covering exponent rules. So exponent rules are very important. You're going to be using them from now until the end of Algebra 1, and you're probably going to be using them for the rest of your math career moving forward. So this is a very important lesson. So I decided to make a video on this in particular because probably the remainder of my videos are going to be kind of focused on this specifically. So in the last video, you probably went over polynomial rules with me. So in this video now, I'm going to kind of go a bit more in depth about exponents and whatnot. And it kind of relates a little bit, but it's also a bit different. So we're just going to dive straight into it. So let's start off. What are exponent rules? So exponent rules are very simple. They're just basically rules that you use with exponents whenever you're given some kind of operations with exponents. So there's a lot of rules we need to make sure we understand. So I'm going to kind of go through the major ones you're probably going to see very frequently. So the first rule we have is the product rule. So the product rule, this rule is basically telling us that if, let's say, I had something to the x power and I was multiplying it times something to the y power, it'd be the same as if I was adding the exponents. So it'd be a to the x plus y. So basically, all I'm saying is that if I have an exponent here and I'm multiplying, if I have the same bases like this, right? I have a, and then I have these things up here, x and y, as my different exponents. We're going to be adding the x and y together. So let me give you an example. Let's say I had 2 to the third times 2 to the fourth, right? That's the same as me saying I was doing 2 times 2 raised to the 3 plus 4. So it'd be 2 to the 7th. That's all you're doing. So if I have the same bases again, we're just adding those two things. Not too hard. Now let's look at the next one. This is the quotient rule. The quotient rule is telling us that if I have a to the x divided by a to the y, that is the same as me doing a to the x minus y. So another way you could probably see this written out is if you were given it as a fraction. So if it was a to the x divided by a to the y, but it's in a fraction, just think of it as a to the x minus y. It's very simple. Again, you have to be dividing, right? And you have to have the same bases. That's a very important thing to remember. If you have the same bases, you can do that. The next one we're going to be doing is the power rule. Now, power rule is essentially saying that if I was, let's say, given a to the x inside parentheses and it was raised to the y power, that's the same as me multiplying a to the x times y. So for example, if I was given 2 to the third raised to the second power, right? That would be the same as me doing 2 times 2 raised to the 3 times 2. So 2 to the sixth, right? That is it. Again, just you have to make sure that it's in parentheses for this rule to work. So that's one thing to keep out for, because you can make mistakes very easily like that. The next one is the power of a product rule. Okay, let me move this over. There we go. So the power of a product rule is essentially if I was saying that if I had a times b in parentheses, and I was raising that to the x power, that would be the same as me kind of distributing this x over into each of the individual parts of that. So it would become a to the x times b to the x. So again, everything has to be in parentheses for this to work. And all you're doing is you're just taking whatever's up here and you're moving it over and making it part of each individual part of the things in the parentheses. So for example, if I had 2 times 3, and I was raising it to the fourth power, that'd be the same as me doing 2 to the fourth times 3 to the fourth, right? Because the 4 is just getting distributed as an exponent for each of those. Not too bad. The next one is the zero exponent. Now, this is my favorite one. So basically, let's say we have a to the 0. That is going to be equal to 1. Anything raised to the 0th power is always going to equal to 1, and that's the entire rule. It's very, very simple. So just anytime you see something to the 0th power, you automatically know that it's going to be equal to 1. So if I had like 2 to the 0, right, that's just equal to 1. Very simple. Now we have two more. We have the negative exponent. So the negative exponent, this one's also pretty cool. So let's say I have a to the negative x. That is going to equal to 1 over a to the x. So for example, let's say I had 2 to the negative third power, right? That's going to equal to 1 over 2 to the third power, which is equal to 1 over 8 when we simplify that out. So basically what we have to look out for here is if we're given a negative exponent, right? That means that we take this whole thing, right, and we put it into the bottom of a fraction, with 1 on the top of that fraction, of course, and then we'll just make the exponent positive. So whenever we're moving from like the bottom to the top or the top to the bottom, we're switching the signs of the exponent, if that makes sense. So our last rule is going to be the fractional exponent. Fractional exponent. And with the fractional exponent, what that means is that, let's say I have something like a to the x divided by y. I don't know if I made that very clear. Let me try this again. So if I have a to the x divided by y, right? That is the same thing as me saying it is, with a square root, a to the x on the inside of that square root and a y right here. So I know that's probably the most complicated one you're probably going to see. So you may see that in a later math class, but I'm just going to teach you guys that in case you're asked about it right now. But that is the rule. So let me give you an example that I always use to help myself remember. So if whenever I'm given something like, let's see, 4 to the 1/2. Oh, that's not a good four. 4 to the 1/2. That is the same thing as me saying 4 to the 1 power, with the square root, right? And just the second square root. So that's just equal to 2. So just always think of this. Think of this example if you're ever struggling, right? And just remember that whenever we are given something like this, it's going to be this. It's going to be where the a is going to go into the inside of the fraction, into inside of the square root. The x will go, onto the top of that a inside the square root, and then the y is just telling us how many times we're taking the square root of something. So if that y part is confusing you, let me give you another example. So let's say that I was going to do, um, let's see, 8 to the 1/3 power. Yeah, yeah, okay, so 8 to the 1/3 power. So that would be like me taking the square root. I'm putting 8 here, 8 to the 1 power, and then it's a cubed root, right? So that's going to equal to 2, right? So that's how it works essentially, and it's not too hard if you just think about it and do some practice with it. But some people do struggle with that. So keep that in mind. Your teacher may not be asking you about that this young, but that is something to keep in mind. So now we're going to do some practice problems. Now, because there's so many exponent rules in this thing, I'm not going to get to all of them in the practice problems. But you could always go to this website called Kuta Software, and they have a lot of practice. That's where I'm getting some of these problems. That's where I always get the problems for my video. So go to that website, check it out, Google it, and they always have a lot of practice on this kind of stuff. So now I want you guys to try it. Try these problems, pause the video, and come back when you are ready. All right, so I hope you guys tried all the problems. Let's see if you got them right. So let's begin. The first problem, let's zoom in number 1. Let's go. So this is asking us if we have parentheses that has 2x to the fourth, y to the negative third, and that's all to the negative first power. Okay, this seems kind of complicated already, right? But it's not too bad. Let's go to our rules, right? What's the first thing we see? So we see this -1, right? Let's focus on the outside of the parentheses first. So whenever something's raised to the -1 power, that's equal to me putting everything over here on the bottom of a fraction. So if it's raised to the -1 power, that's going to be the same as me doing 1 to the 2x to the fourth, y to the third power, and that's all raised to the first power. So that's basically the same thing as 1 over 2x to the fourth, y to the third. And that's actually it, right? Because there's nothing else we could simplify. Oh, wait, no, actually, I take that back. There was a negative third there, wasn't it? Okay, so I did not see that. Let me just undo that. Okay, so let's see. How should we do this? Okay, so I misread that problem. So let's try this again. So we have 2x to the fourth, y to the negative third. I didn't see that. So the negative third, whenever something's raised to a negative power, it becomes a fraction, right? So we're going to start off inside there. So if the fraction is going to be 2x to the fourth times 1 over y to the third. and then that's all raised to the negative first power. So that you can already see we're combining a lot of these rules, right? And then now we have this negative first power to deal with. So that's going to be, oh, that's going to be equal to 1 over 2x to the fourth times 1 over y cubed to the first, right? And then if you think about it, we have, let's just look at like this. I'm going to kind of squeeze out the part of it. But yeah, let's look at this part, right? This highlighted part. What that is essentially saying is we're doing 1 divided by 1 over y cubed, right? If you remember from, I don't know when I learned this, but there's this rule called keep, change, flip. So you can do that rule right here, right? We can keep this, change this, and flip this fraction. So let's do it. So that's going to become equal to 1 times y cubed when we do the keep, change, flip. You may not be able to see it. Let me move over here. Okay, so it's basically equal to y cubed at the end of the day, right? So what that's telling me is that if when I'm doing the keep, change, flip for this highlighted part of highlighted over here, is that the y cubed could go on the top. So y cubed is on the top, and then what do I have left on the bottom? We have the 2x to the fourth. So that one's a little bit complicated, but make sure you try to understand that one, and try to rewatch the video if you're struggling at any parts in particular. Now, number two is a bit more of a straightforward one, so let's see if we can get this one right. So we have 3m in parentheses to the negative second power. So how do we get this one done? Okay, so there's nothing we can really do on the inside here. So let's go to the outside. The outside has has a power of -2. So when we have a negative power, what that tells us is that we could put everything on the bottom of a fraction and just flip the sign on the exponent. Right? That was one of our rules. I think that was the negative exponent rule right here. So what we're going to do is we're going to do 3m. Actually, okay, 1 over. Hang on, it's not letting me type. Okay, 1 over 3m raised to the second power, right? Because we're just following our rule. We have the -2 right here. So that turns into a +2 when it goes onto the bottom of the fraction. And then it's still being attached to that 3m. So now we have to simplify this, right? Because we have 3m being squared as a whole, right? So now we have to go to our next rule where we're distributing the exponents onto each part of the equation. So we distribute the 2 here and we distribute the 2 there. So our new one should look like 1 over 9m squared. And that is our answer. Very simple. The next one we're going to do is number 3. R squared divided by 2r cubed. Okay, so initially you may be like, what could I simplify over here? So there's a couple things we could simplify over here. So number one, we could just do, let's start looking at what we see in common on the top and the bottom. So we see what? We see a common base. We see r's, right? We see r, and then one of them is raised to the second power and one is raised to the third power. So you like you're probably, if you were confused on this one, you were probably confused about the 2 right here, right? Because the 2 is probably is sticking out and you don't know how to do the rule with the 2 there. But that's actually very simple. So what you can do is we can take out this 2 right here, right? Because if there's a 2 on the bottom of the fraction, we can take out a 1/2. Because if you think about it, this is 1 times r squared on the top, and then we have the 2 times r cubed on the bottom, right? 1 times r squared times 2 divided by 2 times r cubed, right? So why don't I just take out this part, right? I could take out this whole thing and make it a 1/2. Oh my gosh, okay. Hang on. Okay, here we go. 1 over 2 times r squared over r cubed. Right? Because if I multiply these out, it would become equal to the same exact thing I got over here. So now what can I simplify from here? Well, let's look. We have an r squared and we have an r cubed. Now I can do my rule, right? I can do my rule where, which one is it? Yeah, one of the rules around here we did where you can subtract them, the quotient rule right here, right? We can do this quotient rule because we have something a to the x divided by a to the y is equal to a to the x minus y. We can do that same rule right here. Instead of a to the x, we have r to the whatever power, right? So r squared divided by r cubed. So we could do r to the 2 minus 3, because we're subtracting these exponents, and that's equal to r to the negative first, and that is equal to 1 over r, because again, it's 1 divided by r to the first, which is equal to 1 over r. So yes, that one was also a bit tricky if you especially did not if you're confused about this too, but you could if you now that you know it's kind of simpler now. Now let's do number 4. So we have x to the negative first divided by 4x to the fourth. So that is equal to what? Well, let's see. Okay, we have an x to the negative first power, and we have a 4 to the times x to the fourth power. So we do that same thing we just did just now, right? We know that there's a 1 on the top here being multiplied times x to the negative first. And then we know there's a 4 times x to the fourth, right? So we could take out this 1/4. So it becomes 1/4 times x to the negative first over x to the fourth. Good. So now what do I do? So let's see. We have an x to the negative first here, and we have an x to the fourth. We have the same exact bases, and we just have different exponents, and it's being divided. So we could do our subtraction, or what part of our quotient rule. So it becomes, oh wait, hang on. For the last one, I forgot to put a 2 here, because again, I forgot to multiply this 1/2. So you're supposed to multiply the 1/2 times the 1 over r, which is equal to 1/2. Sorry about that. So the same thing here. You have 1 over 4 times x to the negative first over x to the fourth. So now what am I supposed to do here? So we can do our quotient rule for this whole thing. So it becomes 1/4, because I have to keep this, right? I forgot to do that in the last problem. If you're confused now, I forgot to put this the fraction and multiply it. So we're just going to keep that fraction with us as we go, and it's going to be x to the negative 1 minus 4. And that is equal to 1/4 times x to the negative 5, right? And then a negative exponent always goes in the bottom. So that would become equal to 1 over 4x to the fifth. Right? Not too bad. Not too bad. Let's move on now. So those were like the I would say medium problems probably that you'd ever see. And now these are some harder ones. So try these out. If don't freak out if you don't understand these ones either. These rules do take a minute to get used to, but just try them out and see how good you could do. So let's begin. We have a to the negative cubed, b to the negative cubed, and that's all inside of a parentheses to the 0th power. This is very simple. The answer is 1, because anything raised to the 0th power is 1, right? The whole thing, everything inside of this is being raised to the 0th power. So everything inside of there combined, multiplied, and simplified is going to equal to 1. So that's pretty simple. That's part of our rule for the 0 exponent. Then we have this one. We have x to the fourth y cubed multiplied times 2y squared to the 0. How do we do this one? Okay, so let's start off on this side, right? What do we see over here? We see a nice 0. And whenever we see a 0, we know anything raised to the 0th power is equal to 1. So that means that this whole thing is just equal to 1, and we're multiplying that times x to the fourth y cubed. Now we can't really simplify that further, so it's just x to the fourth y cubed as our answer. Oh, it's not letting me write, hang on. Y cubed, and that is our answer. There we go. So let's go to our next problem. Oh, hang on. Okay, so our next problem is asking us ba to the fourth times 2ba to the fourth to the negative cubed. Okay, so that's a tongue twister to say. Let's begin with this right side right here. So what do we see over here? We see 2ba to the fourth raised to the negative third. So what that means is that essentially this whole thing is the same as 1 over 2ba to the fourth cubed, right? Because we have because we had a negative exponent right here, and a negative exponent is essentially the same as if I put everything into a fraction and put all of this stuff that was inside that was being raised to the exponent on the bottom of that fraction, like I did right here, and then changing the sign to the opposite sign. So that's essentially what I did right there. And then we're multiplying this still times ba to the fourth. Okay, so now what can I do? So we can multiply the ba to the fourth times the whole fraction thing I have right here. And then that's going to be equal to ba to the fourth over 2ba to the fourth cubed, right? So now what can I do? Well, the next step we could possibly do is to multiply, or actually not multiply, but raise everything inside of this parentheses, raise it to that power, because that's part of our rule. So what would that look like? That would essentially be like me doing, so I had ba to the fourth over, so we're going to raise it 2 to the third, which is 8, b to the third, and a to the fourth times the third, which is a to the 12th. So that's this is using a lot of rules that probably combining all of them that I've gone through. But yeah, 8 to the 12th. So if you are struggling, just keep in mind those rules because those rules are very helpful. And they're probably going to be the reason for why you may get a problem wrong or something. So you need to make sure you understand those properly. So we have this right now. This is what we have. And are we done? No, we're not done. So the next thing we can do, let me rearrange this first. Oh, yeah, there we go. Okay, so I rearranged this now so it looks a bit neater. So let's see what we can do. We can do now. Okay, so now at this point we can do what we did in our last problems, right? We have a we could pretend that we could assume that there's a 1 being multiplied times this, right? So we can assume there's a 1/8 right here. They could pull out. There's a 1/8 times an a to the fourth times b. Okay, so we have b a to the fourth over a to the 12th power b cubed. Okay. Oh wait, no, I actually think yeah, okay. Let me reorganize this again. Um, to make it okay. So I didn't see something. Okay, so this is what it should look like. And now, what we're going to do is we're essentially going to do those quotient rules right here. Now, this one's fun because there's two quotient rules we're going to be doing to each of these things right here. So we're going to split this whole thing up even further now. I know this is getting kind of crazy, but yes, we're going to split this whole thing up further. So we're going to pull out the b's, right? We're going to pull the b's into their own separate fractions. So it's 1/8 times b over b cubed. And we're going to pull out all of the a's into their own fraction as well, right? So all this will be their own fraction. So a to the fourth over a to the 12th. So now what do we do? So now we're going to do our quotient rules with each of these individualized fractions that I've put together. So we have the 1/8, right? Multiplied times b divided by b cubed, which is the same as b to the 1, because it's b to the 1 right here, minus 3, multiplied times a to the fourth, minus 12, because we're, subtracting these exponents as well. And then when we do that, it's going to become 1 over 8, b to the negative second, a to the negative eighth. And then from there, we know the negative exponents will go into the bottom of the fraction and become positive. So we'll put those exponents inside of this 1/8 right here. So it becomes 1 over 8b squared a to the eighth, right? And that is our whole answer right there. So it's very complicated indeed. But again, these problems are very, I think, a bit more challenging, and they're trying to combine a lot of those rules. So if you're struggling with these problems right here, what I would suggest is going online, again, to Kuta Software or one of those other problems, one of those other websites. Khan Academy also has some great stuff, and just start out with some simpler problems that help you learn these rules. And then from there, what you can do is that once you're good at those, you'll be able to recognize the patterns in these more easily and get these problems right as well. So now let's start off with our last problem. We have 2x to the 0 y squared inside parentheses to the negative cubed times 2yx to the 2yx cubed. Okay, another tongue twister. These are all tongue twisters for me to say. So what can I do here? Okay, so we have an x to the 0 right here, right? The x to the 0 becomes 1. We'll put the rest of the stuff. So we have 2 and y squared. all to the negative third. Okay, so you may be wondering right here. So why isn't the 2x to the 0 all being all being put to the 0th power? Well, that's because the 2 is not in like parentheses, right? If it was 2x to the 0, this would be all be equal to 1. But if it's just x to the 0 times 2, it's going to be the same thing as 2 times 1, because it's 2 and then that's 1. So you have to be careful and make sure you notice when there's parentheses and when there's not parentheses. So let's move on from there. Now we're going to go and add this next part on, 2y x to the third power. Okay, so now what do I do? So we see a negative third right here. It's not letting me, hang on, okay. Negative third right there. So what we're going to do is we're going to put this whole parentheses thing in the fraction again. So it becomes 1 over 2y squared to the third. And then it's multiplied times the 2y x cubed. Okay, so now what we can do is two things. Number one, we're going to start off with this. Okay, so we're going to simplify this, right? Because we have to distribute in a way this exponent to all the parts of the fraction. So it becomes 1 over 2 to the third, which is 8, times y squared to the third power. So that's going to be y to the 6th because we're multiplying the 2 times 3, y to the third. And then we're going to multiply this times 2yx to the third. And then from there, it's going to become 2yx to the third over 8y to the third. Awesome. So you would think we're done, but no, we're just starting. Because now we have to take out the fraction, because there are numbers in front of these numbers. There are numbers in front of the letters. So we have a 2 over 8, right? So that's going to turn into a 1 over 4. When we simplify it, because 2 over 8 is equal to 1 over 4. We're multiplying this times, we have to take out all the y's, right? So that is going to be y over y cubed and then times x cubed. Good. So from there, now we're almost done because now we just have to do 1 to over 4 times y to the 1 power minus 3, which is y to the negative second power, and then you have x cubed. So that's equal to 1 over 4 y to the negative 2, x cubed, and then from there, we put our negative exponents on the bottom of the fraction, we put our positive exponents on the top of the fraction. So it becomes x cubed, because that is a positive exponent, so it would go on the top of the fraction, over 4y squared. All right, so these were all complicated problems, I know, but if you're struggling, again, visit the websites I talked about and try them out for yourself, or even take a screenshot of this page in particular, because this page will be of a lot of assistance to you in the future. All right, thank you for watching. Leave any questions you have in the comments as well. Thank you.